Next in line is Natalia Ivanko. Please welcome Natalia.
Hey, my name is Natalia Ivanko, and I work as a security engineer for Isovalent. So probably you have already seen a couple of use cases how one can use eBPF for network policy logging or for measuring CPU overhead. But today I would like to talk about how a security team or a security operations team could use eBPF and the data extracted with eBPF for network monitoring and threat detection in cloud-native environments. So for example, in Kubernetes. We will see a couple of examples how a security team could detect malicious inbound and outbound connections. So for example, how a security engineer could detect an external connection to a suspicious IP, or how can a security team could monitor all the inbound connections to workloads, or monitor which kind of workloads are accessing the KYTS API server. So a little bit about the background. The traditional network monitoring tools are based on IPs and ports, and they are not really effective on cloud-native environments like in Kubernetes, where the workloads are basically containerized and bundled together, and the IPs are frequently changing. So the IPs and ports are not meaningful there anymore. And one of the solutions could be using eBPF and Cilium to grab this data from the kernel, ship it to Splunk, and then define signatures to detect these connections and basically create an alert. So as an example, I already have a GKE cluster set up. It's called eBPF Lab Summit, and I already have an example application. It's the guestbook application from Kubernetes. It's a PHP web application with a Redis backend to store the entries. I can write like, hey, and then we see it's working, and it's running on the default namespace. You can see the pods here. So the first example, I'm going to show you how a security team could detect a malicious connection to an external IP. So let's assume that the front-end pod got compromised because of an outdated PHP version, and suddenly there is a crypto miner running on it. I'm not going to demo the real attack. I'm going to generate the traffic by hand with curl. So I already have the command set up here. I'm just going to exec into the pod. We are in the pod now, and then I'm going to generate some traffic by hand. Yeah, it's a curl against a Monero mining pool. I already looked that up before. And now I already have eBPF and Cilium running on the cluster. And if I go to Splunk and use a signature that I predefined previously, I should be able to see the traffic coming from that pod. So here we go. Basically, on the left-hand side, you can see the source. And then on the right-hand side, basically, you can see the destination. So here we can see that there is the front-end source pod running on the default namespace with the following Kubernetes labels. And then on the right-hand side, we can see that, hey, there was a connection to this like Monero mining pool. And then basically, we can also see that the network policy decision was first dropped and then forwarded. And I forgot to mention that I also applied a Cilium network policy here, which allowed me to detect all the L7 layer visibility here. I can show it to you later on the Slack channel. So basically with this signature, we can see all the outbound connections going from the front-end pod. And on the other hand, we can also detect inbound connections to unexpected workloads. So for example, monitor all the inbound connections and detect when there was a malicious connection to one of the workloads. This can happen when, for example, a Kubernetes service left unexposed unintentionally. So for example, here we have the guestbook application. I have the front-end pod exposed by a service. So I can reach it via curl from my local machine. This is the IP, and I also looked it up before. So I'm just gonna do a couple of curl to generate some traffic. And with the following signatures, I already have it predefined. We could actually see all the incoming connections to the front-end pod. Yeah, so here we have that the destination on the left-hand side. This was the guestbook application, and then the network policy decisions, and basically the counts as well. And here I'm actually monitoring all the inbound connections. So on the above, you can see a couple of other destinations and then a couple of counts. And then basically I just used reserved remote mode, which is basically Cilium specific entity for the remote nodes. So these two examples were a little bit more generic. We detected like a suspicious external connection, and then basically we were monitoring all the inbound connections. The last example will be a little bit more specific. We will detect and monitor like which workloads are accessing the KYTS API service. So I already have the IP of the KYTS API server. I looked it up before. This is the IP. And I already mentioned that I applied a Cilium network policy to detect the ASN layer visibility in the first example. So first I'm just going to delete this network policy. And then, okay, it's deleted. And then exec into the front-end pod. And then generate some traffic to the KYTS API server. I'm just gonna do a couple of curls. Okay, this is not HTTPS. Let's see. It hangs. Okay, so let's try it once more. I forgot that I actually have to add the -k flag. Yeah, we are going to get 403 because it's unauthorized, but it's good for generating some traffic. And then basically with the following signature, we are going to monitor all the workloads which are accessing the KYTS API server. So if I go to Splunk and just insert the signature and go to search, I should be able to see which applications are accessing the API server. So here you can see basically the source, the namespace, the pod, you can see the front end, the DNS, the kubedns, and then basically the Kubernetes labels, the network policy decisions that it was forwarded, and basically the destination IP and the destination port. And I hope it was useful, and you could see that among many others, you could use eBPF, and the data is extracted with eBPF for network monitoring and threat detection in cloud-native environments, and it's super powerful. You could see the source and the destination without any IPs and ports is basically based on namespace, pods, and labels. And if you have any questions, yeah, we can do a Q&A on the Slack channel. Just feel free to reach me out. And I hope you enjoyed it. See you soon.
Thank you very much, Natalia. Awesome presentation showcasing how eBPF will really change security value in Kubernetes, but also obviously outside of Kubernetes.